welcome, welcome. Thanks, everyone. So, as I promised, an exciting, long conversation about workforce development-related topics. So the previous panel was about how do we look at workforce development more kind of globally in the industry, not only from a training perspective, but what does it really mean for the industry in general. This one is going to be more focused on the growing needs for interdisciplinarity that we see in this field, and on the accessibility, inclusivity of workforce development activities and the opportunities. So would you like to start introducing yourselves one by one, and we'll move on?
Sure, thank you. I'm Catherine Lefebvre. I'm not Juliette, but I'm
That's right.
Almost the same. And I'm not at the colorful matter, but I'm at the Open Quantum Institute. So Catherine Lefebvre, Open Quantum Institute, that was created by GESDA, the Geneva Science Diplomacy Anticipator. And I'm a senior advisor for the OQI. The OQI has the mission to promote global, equitable, and inclusive access to quantum computing, and through that develop application or explore application of quantum computing that would help tackle global challenges such as the Sustainable Development Goals.
Thanks, Catherine, and merci for filling in for Juliette, who had a last-minute problem. Maz?
Hello, everyone. Maz Bahrami. I am with Wolfram Research. I'm directing a team called Academic Innovation. Two of my team members are here. If you have any questions, you can talk with them. In our company, we have two flagships. One of them is Mathematica, which is a software that you can use to do any sort of computation, and I mean it literally, any sort of computation. More recently, we developed functionalities for quantum. Then we have another flagship, which is called Wolfram Alpha. Wolfram Alpha is basically, think about 20 years ago, and ChatGPT 20 years ago, but for computational calculation, not for any sort of you cannot write poems, okay? You can do exact calculation. Just a side note, the main difference between the platform that we have, Wolfram Alpha, and ChatGPT is a generative, it's a stochastic natural processing unit. Ours is deterministic. So basically, we don't make any mistake in our calculations.
And you also have the Wolfram Institute.
Oh, yes. So there is, more recently, I guess a couple of years ago, we started a research institute called Wolfram Institute, which is mostly to do let's call them exotic research. We believe the computational tools that we have developed, they can open up new possibilities to explore foundation of science on bio, on foundation of physics, mathematics, mathematics, and that's basically the research side of our company.
Very well. Erik?
Hello, everybody. My name is Erik Garcell. I'm the Director of Quantum Enterprise Development for Classiq in North America, because we have a couple of different geographies. I handle a lot of the enterprise discussions and collaborations in North America and with some of our fun partners here. At Classiq, we have an end-to-end software development platform trying to make quantum computing not only useful, but broadly accessible. It's important to have that diversity of thought and make sure that as many people as possible can access all the great tools being developed, because useful applications, innovative applications will only really happen when you have that diversity of thought and more people able to use and take advantage of this new compute resource.
Very well. Thank you very much for coming. For the first question, we would like to talk about designing accessible interdisciplinary programs. So the need to integrate quantum computing with other fields, of course, AI is. I really hope that in the AI conference they say quantum also, right? What are the roles of different technologies and in ensuring kind of this accessibility, and if you have examples of initiatives for promoting these interdisciplinary programs across the different fields that you navigate? In any order, Talk to yourself.
Please.
Well, I can discuss, present a little bit more what we do at the Open Quantum Institute. Really bringing, it's at the core of it's a science diplomacy initiative. It's a governance initiative, so we're not doing research. We're not developing new education tools. We collaborate with our different members and partners and the global community to put the resources together and then make them accessible, especially focusing on underserved geographies. So what I mean by underserved geographies are geographies that do not have access to the technology or do not have access to the training. And as a science diplomacy initiative in action, it is also providing tools for the scientists and technologists to understand what science diplomacy is. So there is not only bringing interdisciplinarity in developing use cases with quantum experts and classical computing experts and subject matter experts, and also UN organizations that are validating the type of use case that our friends here are working on, and even yourself. But it's also giving tools to translate for policymakers and diplomats, and give them tool to speak a different language for different people. So that's one thing that we are doing, and also learning about sustainability, learning about responsible computing. We're just starting this initiative, for instance, with EPFL in Lausanne, and they have a master program in quantum computing, and they will have a new course on responsible computing and SDG. So it's collaboration with the Open Quantum Institute, where we'll provide a resource and also bring our experts so that the students are exposed also to this, and not only focusing on building something, but also are learning about impact as they're learning. They're getting.
Right. In other words, accessibility and interdisciplinarity are in the very fabric of the initiatives that you launched.
Absolutely,
right?
absolutely, and it wouldn't be possible without the whole community that is working and collaborating with us.
That's right.
So we're this platform that brings this interdisciplinarity in itself.
Right. How interdisciplinarity and accessibility plays at the, with your platforms?
Well, I'll say a little bit of background, actually. We very much believe in the OQI mission, which is why Classiq and Wolfram actually have a proposal for the OQI initiative to create useful quantum applications that will bring some good, right? The actual concrete, useful tool development, application development in ways that will be broadly accessible and useful. It's important to build these tools and build this collaboration, and just a little bit of background, since we actually already know each other on this panel.
That's right.
Yeah. But I think to make quantum computing more accessible, to add to this diversity, I think it's important to work on some of the articulation going on in quantum computing. Quantum computing comes from a place of physics, right? That's the lens through which it was developed through. And I think we still have a lot of holdover jargon that comes from this physics background, right? We use a lot of acronyms, we use a lot of quantum terminology that I think we need to work on as a community to undo, to make it less insular in how we communicate this technology, right? If we remove jargon, if we remove these kinds of industry-specific language, it makes it a more accessible technology. If it sounds confusing, if it looks complicated, you're gonna put some people off.
Yeah. So I cannot say Hamiltonian.
Well, I think that's a challenge too, if I may.
Of course.
Making it accessible and removing the barrier with less jargon, but keeping the rigor. And that's where it's such a challenge. Like, how do you explain entanglement in a satisfying manner? I have not.
Well, how can Mathematica help?
Historically, basically the mission of our company was to make computation easy, independent from your expertise. Okay, look, just this morning I wanted to solve a very fancy, time evolution using, a very fancy Hamiltonian, and I had no idea what was the mathematical relationship between a bunch of Bessel functions, Airy functions, etc. So, but I wanted to find the answer. I'm not an expert, like, in those, like, calculus topics. Yes, I passed courses on that, and actually we were just discussing with Catherine and Erik about that, but God knows how many years ago. But I want to find the answer. Okay, so I need a tool that helps me, although I'm not the domain expert, but I can, like, identify the problem, and I'm expecting a result. So these are the type of, like, computational tools that we are creating, like, in our company to help users. You don't need to be an expert on topic X to do computational X.
That's right.
And that's the thing that has been, like, the mission of our company for more than, like, 35 years. More recently, of course, a very powerful tool has been added to everything that we are doing, and that's Gen AI. So basically, like, right now, before everything was still very abstract. So you had to write down a piece of code. You need some formal language, some abstraction. So you couldn't just tell a software, hey, I want to solve this integral, and this is, like, this function, Bessel function of, first kind, and in this domain, et cetera, et cetera. You have to reduce it into mathematical abstraction, and then the software can take care of that. Right now, we have reached a level that, with Gen AI, you can do that. So you can have, like, a conversation, literally, like what Catherine said. Can you tell me, like, more about concept of entanglement? Can you, provide an example, an experiment showing, like, what is the true meaning of, entanglement? And these are the sort of quantum plus AI. These are, like, the functionalities that we are developing in our company, help people, non-experts, to understand those concepts.
So what do you think of what are the strategies, the best strategies to foster kind of a communication between quantum, the quantum space and adjacent fields? Do you think that the platform is, like, the tool is the solution for that? Do you think it's more like a policy thing, a programmatic process? What are the best strategies you would say for promoting this engagement across fields?
I think quantum is already an interdisciplinary field, right? Quantum computing is a tool that will be used by many different industries.
We like a lot to talk about health, but not so many experts in health sciences in the quantum space, right?
Yes, exactly. And I think what's needed is to demystify how to use quantum computing in those fields, to show what that path to success looks like. To show how you can use these, maybe esoteric equations to the healthcare facilities, but show them what the end use can look like if you go ahead and use quantum computing, right? We talk about QAOA and all these variational algorithms and things like this. Well, let's translate that into protein folding. Let's make sure that it's explained in a way that makes sense to the field we're talking to, and show them the output that can come if you decided to use quantum computing in that field. If you show the path to success, it demystifies, how do I use this, what do I use it for, and why is it useful for me? To show them that step-by-step process. How do you make those connections? How do you build that out? And the more we can show industries why quantum computing is useful and how to use it for that application that might be useful for you, the easier it'll be for end users to adopt the technology for that case.
One example that comes to my mind, like, my generation, like, the very first computer that I purchased, I had to get different pieces, CPU, motherboard, like, graphic card, like, et cetera, and I had to assemble them together. And then I had to install, like, an operating system, and then each piece I have to install it separately. So it was like, 1 week job just to have a computer. Right now, what you do is you just purchase the whole package. So everything is ready. That's why, like, new generation, many people, they have no idea what is an operating system. Our generation, like, we started with DOS, and then, like, et cetera, Windows, et cetera, et cetera. But anyhow, what I'm trying to say is, these are the tools that you provide. Like, you go to the higher level. Okay, when you reach a proper level, then, like, many different users, they can use that because it becomes user-friendly in a sense. Like, so the users, they don't need to think about, like, should I install graphic card? Should I, like, I don't know, like, if I want, should I care about, like, operating system, et cetera, et cetera. But that's one level of users. Even among, like, those users, there are some people, they want to dive in, they want to go deeper. And of course, there are better tools for them. So we need to basically provide a tool that can go very high level, and then all the way, if they want to go lower level, by all means, let's do that. And it's not easy. Like really, tool making is a very, very complicated, time-consuming, costly process. Like look at our company, we are providing computational tools, and they are badly expensive, badly expensive. And one of the things that I think, like, you know, especially quantum industry, we should do better is talking with each other and sharing, like, you know, the experience. Like, you know, one thing that I noticed is that in the quantum industry, many of us, we are reinventing the wheel. One company has their own SDK, then another company has something similar, then another company does the same.
And the Mathematica does.
And then, like, you know, Mathematica was there, you know, 30 years, and you would say, oh, so the things that you implemented, linear algebra, it was already there. I think, like, you know, it's good in a sense. We need that, like, you know, many different tools. But in the meantime, we have to talk with each other because once we talk, like, again, think about that example. Like, when different companies, like, you know, the computer manufacturing companies, they start talking with each other, they put the pieces together, and now they give a package to the user. And that's the level that we have to reach with quantum computing.
Okay. Do you think that that's the pathway? Like,
I think there's not one pathway. I think there should be really diverse opportunities. And thinking of other examples are, for instance, like hackathons that bring a mix of business people, quantum expert and domain experts to brainstorm for a short period of time. Well, the question is after what's after the hackathon. That's still there, but it's an introduction into and there are challenges that are out there that are coming more and more. Like there was a quantum for bio challenge that brings diversity and different perspective to do something ambitious. There's the X Prize competition on quantum application. There's the ARPA-E on energy and material. So I think it's starting with the shift of looking and bring the domain experts with the quantum experts to, but still this is at the level, maybe at the professional level, but they're like the competition for X Prize, any students can participate.
So could I read like an optimistic view from what you're saying, that actually we have, at this moment, we have a pretty diverse set of programmatic activities and tools to enable this?
I don't think that. I think it's just starting. It's not.
I think it's just starting.
Yeah, I think it's really starting. I saw there's a new challenge in Japan for quantum and social good, and then even in Saudi Arabia. And so I think it's starting, but it's really we're a small community of quantum experts. There's a large community out there and it will. What OQI is doing with the Education Consortium, bringing these tools that our collaborators are building and making them available to underserved geographies is one way, and then we need to expand this network and more. So I think any idea is good, and it needs support. So back to your question about policy, and then what are they? Is it should come from government to support these? I mean, big question mark. Maybe a question for you.
So let's talk about the challenges then. Given the point of diversity, right? What do you think are some of the challenges that you have seen that companies or the industry has for both inclusion and retention? Like, is there a challenge for retention? Is the bigger challenge inclusion? What would you say?
So how do you define retention in quantum while it is such a nascent?
It's not so nascent. I mean, the UA has been around for 30 years. Okay, we have an industry that I appreciate it's young, but you do see movement, and particularly with the competing forces of the traditional industry and the hot topics, right? I don't want to say AI again, but I already did. So there is I would say that we see movement, and that movement may be desired or not, right? So that's what I say by retention, our capacity to navigate this movement of talent into and out of.
Yeah.
You know, I think, like, one major difference between, like, let's call it quantum industry compared to any other industry is that when it comes to workforce training, the heavy load is still done by other people rather than this industry itself. It is done mostly by academia. And that's a major difference between like, you know, historically, like, you know, other industries who were also involved with like, you know, training their own like, you know, workforce and quantum. And this is maybe the fact that we need to be more honest about that. We should say, hey, like, you know, we have a topic, very technical, very complicated. We need technical people to do the development. Yes, we want to bring like, you know, the final product at the level of like, you know, basic users. But those developers, they are still coming from a place like academia, and the main resources to train them is again coming from mostly public sector, government, etc. I think like, you know, having this reality and like, you know, just acknowledging that, it helps us a lot in terms of, okay, what we should do next. Because if this is the reality, then when it comes to the workforce development, academia's involvement, it's become a big deal. Like, it means all of us, anybody in the quantum industry, we need to have a very close relationship with academia. Because they are taking the heavy load. They are the main force behind like all the trainings.
Innovation is still very part of it, and academia is a big part of it.
They are still the main driving force.
Yeah, I mean, also it's still very much research and development with a big R.
And a small D.
I mean, there's so many challenges in thinking quantum computing, developing the hardware and scaling it, and the algorithm, like, also bring them to be less resource consuming. It's still a research. Centric, I think, and we'll continue to make tremendous progress. But
so you would
expect it's the entry that how to get into is still very technical, as you mentioned.
So despite the push, would say that we see for many workforce development activities today to kind of climb down this degree ladder. You would say that the role of the PhD, of the person that is trained to do research and innovate, that the importance of that role is not going to go anywhere.
I think there's a little bit of a difference here. I think there's workforce development that's needed for those who are developing the technology, and workforce development that's needed for those who want to be consumers of the technology. And I think those should be different development programs. I think there is a role for upskilling workshops or programs to take current computer scientists, engineers, programmers, and upskill them to be able to create and deploy quantum circuitry, right? The quantum algorithms. You need a lot more physics knowledge if you actually want to be working on the hardware itself. But in the same way that engineers and programmers don't learn about how an electron travels through a transistor, you learn how to use the technology, right? That's not part of the education program, right? You don't have to understand the underlying physics of classical computing to be a consumer of classical computing and program for it. So I think there is room for an upskilling program that does need to be developed. We need more of this from industry. We need to see more of these programs being developed to upskill the existing workforce who wants to learn this new technology, right? There's huge swaths of engineers who, when AI came along, they want to make sure that they have the expertise for this new technology. Quantum is the new thing as well. As new technologies get developed, as new applications for programming get developed, there is a hunger to be at the forefront. We see this with even students in university. They're starting their own quantum workshops and programs and teaching themselves this new programming methodology when the universities don't have degree programs. And we're seeing more and more of that from universities, which is fabulous. But I think this needs to be added on with industry work. We need to see these industry programs for upskilling and continued education in this field.
Okay.
Can I add something? Please. I think there's still a need to continue this culture shift in academia, because there is mostly you go to academia, we did our PhD in physics, and then there's only one way of success is to become a professor, and then so slowly there's a shift, but it's very just starting, like realizing there are so many different opportunities at the after the undergrad and masters, and also after PhD. That you can go into research, you can go into developing the technology, you can go into policy, you can go into educating, and all these is. I mean, that didn't exist when I was a student.
Yeah,
and slowly you see more and more of these programs with internship and industry, and it gives exposure, but it's not up to the student, it's up to the university and the faculty to change the culture.
So what you're saying is that the branching of opportunity types naturally promotes diversity as well, because it promotes diversity of interests and interesting. Okay. Again, I don't want to be too greedy, so do we have questions from the audience? I don't know, Jérôme, if you have questions from the QR code. Jérôme, where are you? Any questions from the audience here?
Hello, everyone.
Aha, hello. Got you.
Yes, sorry. So we have questions that are from the first panel. Maybe we can see if
let's try those. Let's try those.
Start a discussion here.
Keep it exciting.
Yeah, who is sitting?
Meanwhile,
exactly.
Okay. Feel free to use the QR code to submit further questions for the current panel. So one question is, speaking of educating customers of the quantum industry, what do you think could be mechanisms to help encourage customers, and how could we fund these mechanisms?
One of the key points is like, whatever product you are giving to your customers, documentation. I cannot emphasize less how important is this. And yes, as many of you know, in our company, we are spending huge amount of our resources on documentation. It's extremely important. And that's sadly, a common mistake by many people, especially developing a software. Bare documentation, you make your life of your users much easier.
Who usually builds documentation for Wolfram? Is it PhDs, people with PhD degrees, or not?
And our company, we are surrounded, I guess, 75% physics PhDs, the rest, maths, PhDs, it's mostly like that. But, the same technical people, the guy who are developing, those functionalities, they are the one who should be patient enough and write down the documentation. It's such a, time-consuming, and this is one of those things that you hate every second of that, but you'll be surprised how much your users appreciate a detailed documentation.
Can you use ChatGPT?
These are very good point. We are not there yet. We are experimenting, with Gen AI, and my team here, they can show you lots of demos. It's not there yet. Maybe with the next model, maybe with with the things that we are playing around, maybe there might be some room. But you still need a domain expert, for those documentations.
So actually, this is interesting. I mean, we talk about climbing out the degree ladder because there are many activities. We were talking about this in the previous panel, that there are some activities that you're doing with a person with a PhD that you don't need a PhD to do. Do you need to hire someone that doesn't have a PhD, or do you need a tool like an AI tool that makes that process easy and you keep the person with a PhD?
It depends on what you want to be doing with quantum, I think, is the real answer. What are you looking to do with this technology, and how are you looking to deploy it, right? I think you need definitely domain experts in whatever field you're going to be using this tool for. You need somebody, I don't think you need a PhD level to be a user of the technology, but I think you do need to understand quantum algorithms and when you should use them and why you should use them, and understanding the scope of quantum, right? We're not going to be making faster calls on Zoom using a quantum computer, right? So making sure there's people in place who know the expectations of quantum I think this is important, but you don't per se need a physics PhD to have that understanding, right? To have that skill set and learn. There's lots of resources out there for people to learn and educate themselves. In fact, we're seeing a lot of this, a lot of self-education in the field, and a lot of expertise coming from those who aren't quantum experts, right? You can see any of these hackathons. A number of them are being won by people without PhDs in physics.
Yep.
Well, also, many of them don't accept person with a PhD to apply for them. Jérôme, one more question, maybe?
Yes. So how can workforce development with quantum also teach generalizable skills to encourage funding and participation?
Oh my!
Ooh.
Like I wish quantum formal. This is the most beautiful theory developed by humankind in the history of humans. Like you have no idea how beautiful is this formalism. Only if it's just, I know there is this big the learnings, what's that thing it's not easy, but when you start playing along with that formalism, you'll be surprised. It gives you lots of amazing insight. It's just the mathematical beauty and how enriched and how powerful it is. Gosh, this theory we have tested with every possible experiment in the world, and it came out successful. Believe me, for the past 100 years, the best scientists in the world, they try to falsify the most successful theory. So just think about when you're playing with that theory, it's so rewarding, and I think this opens up lots of possibility for whoever is playing with that tool.
I think we need also some education earlier on than just when you're in college and seeing quantum for the first time. That's what makes it alien and confusing in the first place. If we teach quantum concepts in the same way you teach chemistry in K-12, right? You don't start off with equations. You start off with ice will melt, right? You start off with it evaporates. So if you can teach some basic concepts early on, it makes it less of an alien topic. And the same way you learn in grade school, the complexity of the topic gets more and more complex as you go in higher grade levels. You learn a little bit more, right? You learn that there's phases of matter instead of just, ice melts. And it gets a little bit more complex until you reach the equations. If we teach quantum computing in K-12 education in this kind of methodology, it will demystify the concepts that are inherent in this and what makes it an alien topic to begin with.
Any comment?
No, but we can learn why lobsters are turning red when you cook them. It's a quantum effect.
Believe it or not.
It's a quantum effect.
Okay, so I will invoke my chairman greediness, and I will leave the last question. Thanks, Jérôme. So can you leave us with one comment on an ethical consideration that should be made when considering policies for diversity and inclusion in quantum?
That's a heavy question.
Yes,
I know.
Yeah.
I don't know policy, I'll say, but I know ethically I'm always very careful, and we're very careful about this other company, to properly articulate quantum, right? To set proper expectations, to not overinflate expectations, to not misappropriate results and overinflate things. It's important to be good disseminators of this technology because it is complex. And as part of the industry, it's our responsibility to properly explain this and articulate it truthfully, honestly, and clearly, without talking about multiple dimensions or all these things that might be very fun to talk about or say or sound very exciting, but take away from the ultimate message of what we're trying to do, which is there's a very cool new compute resource that we're trying to develop, and it has a lot of fun applications.
Personally, my main concern, not only with quantum, any other science, when it comes to defense, that's the part that worries me the most, and and I think also quantum, AI, everything, they have lots of potential in defense, which are great, it's we are working on that, quantum sensing, et cetera, but we need to be very, very careful about those applications too.
And the way we approach it at the Open Quantum Institute is the ethical aspect is responsible computing, like know how you responsibly develop the technology and how you responsibly use it, whether it is for defense or not, and make sure that some of the effort and the resource that are used are steered towards application for good, for impact on the society, and then you know what you're doing, right? And then and the aspect also on global access to it. There are bright minds all around the world that can participate, but it's like, how do we promote this global access and keep it open as possible, keep it as safe as needed, and that's also in the way how responsible we are in the opportunities we put out there.
Very well. Thank you very much. A hand for our beautiful panelists.
Thank you.
And until next time.